The Journey by Ryland Hauser, Ryan Sarriedine, and Makena Tchejeyan. Linear Multiple Representation Web, Part 1. We got this table from 2-5-1. We need to write an equation for the line containing the points shown. Table to equation. Linear Multiple Representation Web, Part 2. Table to equation. So you take 2 x's and 2 y's from the table, and you put it down at the bottom, x1, y1, x2, or y2. And then you put that next to each other. So you put y2 minus y1, which gives you -4. And then x2 minus x1, and that gives you 1. So your final slope is -4. And then you put it into the equation, and you add x to the equation, and then you solve it, and you get b equals -3, and your final answer is y equals -4x plus -3. Equation to graph. Equation to graph is shown here. Graph the situation. In the beginning of the coronavirus that started in China, 3 people died in Ventura County. As days went by, 4 more people died. Linear recap. Table. Graph. Equation. Situation.
Exponential multiple representation web part 1. We got this graph from problem 759, and we need to find a possible equation in y equals ab to the x form. So we went from the graph to the equation. And for the equation is y equals ab to the x plus k, and k is 0, and from the points from the graph, 0, 7, the x is 0 and the y is 7. So we plugged that in to the equation, and it's 7 equals ab to the 0, and then from there it's 7 equals a times 1, which is basically 7 equals a. And from the graph, the other points had 3 and 56, so we put in that for x and y, and we got 56 equals 7 times b to the third, and then we divided them both by 7 and got we got 8 square rooted equals b to the 8, which is also square rooted, and then we got 2 equals b, and then the final equation is y equals 7 times 2 to the x. And then we got, from the equation, we got to the table, and we plugged in from the points from the graph, and we multiplied the 7 times 8 and just kept going. And then we added 3 to the 0 and just kept going for the x and y. And then from the table, we made a situation. And the situation is for every 3 subscribers that Logan Paul gains on his videos, he gains 8 times as many views. He will now make a lot more money. And here's a recap of everything that I just said.
Quadratic multiple representation web part 1. Generic rectangle / equation. We got this problem from lesson 8, number 3, and we have to find the sum and the product for the generic rectangle. So it gave us a generic rectangle, and we had to put the numbers on the side of it. So for 6x squared, we put 3x on one side and 2x on the other side. And in the box in the right corner, we put 5, because 3x plus 5 is 15x. And then for the top left box, we put 1, because 2x times 1 is 2x. And then we transferred it, so we just put addition signs in the middle. and put it below. Then we FOILed to get 6x squared plus 15x plus 2x plus 5. And then 15x and 2x are the same, so you add them, and then you get your final equation, 6x squared plus 17x plus 5. Then we'll transfer our generic rectangular equation to a table, and when we do that, to get this, you plug the 0 in for the x's, and it equals 5. Then you plug the 1 in for the x's, and it equals 28. And then you plug the 2 in for the x's, and it equals 63, and so on. And then we take the table and put it into a parabola. So first you plot your vertex and your x-intercepts, and then you put your parabola, and then you plot your y-intercept, which is 5, and then your vertex, which is -7, and then your 2 x-intercepts. So then we take this and we put it in a situation as if you're diving into a pool, because it makes the motion. So since your y-intercept is 5, you put, I dove off of a 5-foot-high diving board to the left, because it's a negative, 0.5 feet from the edge, because that's one of your x-intercepts. And we went down to the deepest of 7 feet deep, because that's your vertex, into the water, and came out 3 feet from where you started, which is your second x-intercept. And that's our situation. And here's a recap of everything I just explained, which is the table, the equation, the parabola, and the situation. And now here's the analysis.
Analysis, tables, similarities, and differences. The similarities between the tables is they all have x and y in front of them. They're all x and y tables. They all have a pattern, so plus 1, plus 1, plus 1, plus 1, plus 1, plus 3, plus 3, plus 3, plus 3, and then plus 1, plus 1, plus 1. So they all have a pattern within the x-intercept. This one does have a pattern. This one does have a pattern, but it's different because it's a multiplication pattern. An addition pattern where you're adding, but you add, like, you double the addition. So that might be one of the patterns, but the similarities and differences are basically just that. So yeah, thank you.
So this is the similarities and differences between all the situations that we had for the linear web, the equation web, and the quadratic web. So first I'm going to read them all. For the linear web, our situation was in the beginning of the coronavirus that started in China. 3 people died in Ventura County. As days went by, 4 more people died. And for our equation web, it was for every 3 subscribers that Logan Paul gains on his videos, he gains 8 times as many views. He will now make a lot more money. For our quadratic web, I dove off of a 5-foot-high diving board to the left 0.5 feet from the edge and went 7 feet down into the water and came out 3 feet from where I started. So these have similarities and differences. First, the similarities between a linear and equation. They were both made after the tables. We use the tables to find to make the situations for linear and equation. They both only have 2 numbers in them that we're using. They're both very similar. And then quadratic's a little different from the 2, but the differences from quadratic and the 2 is that we used a parabola to make this, but they're also similar because we used our y-intercept and our x values to find all of our points, but for the quadratic we also included our vertex and both of our x-intercepts within it. And that's the similarities and differences between the 3.
The equations, similarities, and differences. all three of the linear, exponential, and quadratic, the final equation for it all equaled y. We didn't write that for the quadratic one, but it does. And for the differences, we got them from different representations. Like for some of them, we got them from a table or a graph, or it just started with an equation, and that's how we did all four of the representations. And for the quadratic one, we used distributive property in it, and for the other two, we didn't. And from linear, we started with a table, and from there we got the points, and there's no points in either the other two. And for the exponential, we used the square root, and we didn't use that for the other two. And for the quadratic one, we used a generic rectangle, and we didn't use that for any of the other two. But for all three of them, another similarity is that we added like terms, which got our answer for all three of them. And that's the end of our journey project. Thank you for watching, and I hope you guys enjoyed.